In this video, we're going to talk about the connection between numerical limits and graphical limits. So in this case, we're going to look at this function right here. It's just a polynomial function, a quadratic, right, a degree 2 polynomial. We're just going to pick some random number to plug in. Let's just say we're going to pick 1 and plug in the number 1 and simplify that out. And so we're going to get a y value of 3 here, right? So for an input of 1, we get an output of 3. So the x value would be 1, and for f of x, then we would get 3 for that particular x, right? And so in a table, that would look something like this right here. So what that means graphically, right? If we have the graph of f of x equals minus x squared plus 4, right? Then the point 1 comma 3 is a point on the graph of the function, and you can see, right, it's right there. Okay. So for every row in your table, you have an x value and a y value, or f of x value. That's going to correspond to some point that's on the graph of the function there. So, and sort of another way that I like to think about it is that this x value is located on the x-axis. So for this particular one, right, it would be right there. And then if I go straight from that x value up or down vertically until I hit the graph, so in this case I would go up to right here, right? That distance right there is 3 units, right? It's 3 units from the x-axis at the point 1 all the way up to the function right there. So that's that y value. Another way, again, I like to look at it is if I'm at that point right there and I look straight over to the y-axis there, I would be at 3 on the y-axis there. So that's the connection between the numerical data that we have and the graphical data that we have here. So what we want to do is sort of be able to take a look at graphically at the limits. So we're just going to take a look at this one example here. This function is slightly more complicated, right? It is a rational function. It is a polynomial divided by a polynomial. And so we want to take a look at the limit as x goes to -1 from the left, the limit as x goes to -1 from the right, and then the two-sided limits. And so the graph I have over here in Desmos, and so I'll share this with you so you can use this if you like. Here is the function just typed in there. F of x is this rational function, and so here's the graph. You may have to zoom in and out to get a good picture of where you're taking the limit, and we want to take the limit at -1 is where we want to take the limit. And notice here, this part will actually give you the function value at -1, and we can see that this function is undefined at -1 right here. The reason being is if I plug a -1 in for x up here, I can see that the bottom part will be equal to 0. And I can't divide by 0, right? That's a mathematically meaningless expression. So this function is undefined at -1, or another way of saying that is that -1 is not in the domain of this function. This little slider here will allow me to move the red bars back and forth somewhat. And so you can see, for instance, here, if I have the red bar located here, that would give me an x value of -0.2, and just like we did on the previous slide, right, we go straight up to the function right here, and straight over we can see what the y value is, or at least get a picture of the y value. Here on this thing on Desmos, right, the x value where the red bar is at will be -0.2, and then this will give you the y value, so about 0.752 right here, a little more than 3/4, so that looks right on this one here. Okay, and I can move that around either through this slider, right, or I can grab this point itself and kind of move it around. Okay. So the first limit that we want was the limit as x goes to -1 from the left. So we are going to go along the x-axis here, and we are going to move closer and closer to -1, right? But staying on the left-hand side. Okay, and so it's going to kind of look like this. We're going to be moving closer and closer to -1, always staying on the left-hand side. And then what we're looking for is the height of this bar right here. This is going to be the y value of this point right here. And so we're going to look and see where that's heading to, where those y values are heading to. Okay, so start over here, get closer and closer to -1 from the left, a little bit closer. I'm moving a little closer, a little closer, a little closer, a little closer, a little closer to -1. And so you can see as I move closer in there, what's happening to the y values over here. They are getting closer and closer to -2 right here on the graph. Okay. Another way to look at it is I can follow along the graph, right, as the x values are getting closer and closer to -1. So this point is moving in. You can see where the x values are up here. They're getting closer and closer to -1, right, from the left. Okay. And so where are the points headed towards? They're headed towards this point right here, right? That point right here has an x value of -1, and there's not really even actually a point on the graph, but the y values, as I get closer to that, the y values are getting closer and closer to -2 on here. So what I would say on this one is that the limit as x goes to -1 from the left of this function is equal to -2. So now we want to take a look at the limit as x goes to -1 from the right of the same function. So this time we are going to start over here on the right, and we are going to approach -1 right from the right here. And then we're going to look and see what happens to the height of this bar right here. Or another way to look at it again is to follow the point along the graph. Okay, so as I get closer and closer to -1 from the left here, right, we're going to see the same sort of behavior here, that vertical bar gets closer and closer to -2. Alright, that's about as close as I can get. Alright, so the closer this gets to -2, right, the closer I'm getting to that point right here, and the closer that those y values are getting to -2 right there. So again, on this limit, we would say that the limit as x goes to -1 from the right of this function is also equal to -2. Right, so now we know both of the one-sided limits. We know that they're both equal to -2, and so therefore we know that the two-sided limit also has to be -2. And so that's an example of how you would use the graph of a function to analyze limits.